Welcome to this lesson on the concept of mole and relative mass in chemistry. The mole is a fundamental unit used to measure the amount of substance. Actually, it allows the count of atoms, molecules, or ions in bulk quantity, making chemical equations or calculations much easier for us in chemistry. So when we talk about mole, we can say that a mole represents the amount of substance which is also called Avogadro's number. Like we can say that 1 mole is equal to 6.02 into 10 raised to power 23 number of particles. So what does it mean? When we say that we have 12 eggs and 12 eggs, we also say it like we have 1 dozen of eggs. So why we use two different units to describe the quantity of eggs? Because 12 eggs is a large quantity, and when we say that 12 eggs are equal to 1 dozen, it means that we can use in more suitable way to describe the large quantity in a easier calculations like 1 dozen. It is a small value and we will represent 12x in the same way. So likewise, when we go that we have 6.02 into 10 raised to power 23 number of particles, it's a large quantity and we cannot use such a large quantity in calculations further. So we will write it like 1 mole. We can use it in a more easy and convenient way in different calculations in IB chemistry. So what does it mean? 1 mole of any substance is equal to 6.022 into 10 raised to power 23 number of particles. Particles may be atoms, ions, or like we can say that it is Avogadro's number 6.02 into 10 raised to power 23 particles, which is equal to atoms, molecules, or ions, or maybe electrons. So it helps us to describe the microscopic and macroscopic quantities. And why we use actually moles? Because mole is a small quantity. When we say that we have when we have large amount of molecules, we will write it in a smaller way, in a more convenient way, like we can say moles. How we will calculate the moles and relate with molecules? We have a formula for molecules which is equal to moles into 6 into 10 raised to power 23 molecules divided by mole. So we can see that if how many moles are there in 3.011 into 10 raised to power 24 atoms of carbon. So we will write it like 3.0 into 10 raised to power 24 atoms divided by 6.022 into 10 raised to power 23 molecules over mole, which is equal to 5 mole. Now we can see that like large number of molecule are present, which we will represent in small moles, small number of moles. So we will use moles in place of molecules. And what is relative atomic mass? Relative atomic mass is used as average mass of an atom compared to 1/12 of the mass of carbon 12. So relative atomic mass is the average mass of an atom, which we will always use when we compare it with 1/12 mass of carbon atoms. Since atoms are incredibly small, their individual masses are compared relatively rather than the measured in grams. The atomic mass values are found on the periodic table. Easily, we can find them on the periodic table. Like we have the atomic mass value of oxygen, which is 16 and written in the periodic table. Every atom has the atomic mass value, which is given in the periodic table. And we use carbon 12 as a standard reference for atomic mass. So we can say that one atomic mass unit is equal to 1/12 of the mass of carbon 12 atom. And like in the example, we have given oxygen. Oxygen has an atomic mass of 16. What does it mean? Like we can say that meaning an oxygen atom is 16 times heavier than the 1/12 of the carbon atom, because we are going to compare it with carbon 12. Like we have the picture that shows there's carbon 12, and it is the picture taken from the periodic table. So we can say that carbon 12, the 12 is the value of relative atomic mass, which is given in the periodic table. So we have the values of relative atomic masses from the periodic table. Now, what is the sum of relative molecular masses and how we will find them? Relative molecular mass is basically the sum of the relative atomic masses of all the atoms in a molecule. And it is basically a ratio, so it has no unit. Now we will calculate the relative molecular masses of carbon dioxide. How will we calculate this? We will take the values from the periodic table, which is actually the value of relative atomic masses. Like we have carbon, and carbon, the weight of carbon is 12, and we have one atom of carbon. So 1 into 12 plus oxygen. The relative atomic atom oxygen has the value of 16. So 16 into 2, because we have two oxygens. So the value of the relative molecular mass is 44. We can calculate in this way.